Okay, so the remainder of this unit is going to focus on the normal curve, otherwise known as the bell curve. You can see it pictured here in the packet, and obviously named as such, seeing as how it's shaped like a bell. But the real details that we're going to focus on for this is the fact that if I go one standard deviation to the left and to the right of the mean, I should always capture approximately 68.26% of the data. And we can get that data more accurate depending on how large our sample size is. So we're going to kind of practice a few questions here where we analyze it by looking at this chart and also analyze it by using the calculator. So if you have a calculator, go ahead and open it up and open up to a calculator page. So the first example here shows the bell curve, and it says, for a population that is normally distributed, we need to see that phrase in order to know that we're going to be using the bell curve. Find the percentage of the population that lies A within one standard deviation of the mean. So we're calculating the total percent from here to here. Now that's just a simple addition of 34.13 and 34.13, or as given in the chart above as 68.26%. Now we're not always going to be given this chart. In fact, we're going to need to know how to manipulate our calculators to find this information. So on a calculator page, we go to Menu, Statistics, Distributions, okay, because this is a normal distribution, and we are going to go to Normcdf, Normal Cumulative Distribution Function. Our lower bound on your calculators will most likely be set to negative 10e to the 999, which is negative 10 with 99 zeros and 999 zeros. That's the default, most likely because we're going to be talking about percentiles with this. But in this case, we are calculating from -1 to +1. You can see that, again, highlighted here on my bell curve. So I'm going to put -1 as the lower bound, +1 as the upper bound. These numbers, for now, we're going to keep them as 0 and 1. This number, the mu, is the mean. It's another symbol for the mean. And there it is again, sigma is the standard deviation. And we're going to be saying taking step sizes of 1. So we're going to keep that as the default of 0 and 1. So when I hit enter, there it is, 0.6826. And it's even more accurate than the chart I have here because it goes out to 6.82689. So actually, if I rounded correctly by using the calculator, I probably would have had 68.27%. And it's going to be variable based on how many data points we have in our normal curve. Okay, so then the next one says within 2 standard deviations of the mean, you can see that that's 95.44% according to the chart. And so what I would have to do for that one is I would go to Menu, Statistics. So if I hit 6 for statistics, distributions, I hit 5, and Normcdf, I hit 2. And we would go from -2 to +2 on the bell curve. And I hit that. You can see I get 0.95449. So really, again, according to the calculator, 95.45%. And honestly, I'm going to say that these are the correct answers because everything we're going to be doing is not going to be given a chart. We're going to be doing it based off our calculators. So within 2 standard deviations, C says more than 3 standard deviations away from the mean. This whole curve is supposed to amount to 100% of the data. So if I go 3 standard deviations away, 99.74% is within 3 standard deviations. So more than 3 standard deviations would be everything that's outside of that, or 100% minus 99.74%. Okay, we could also do that here on the calculator as 1 minus the Normcdf. So menu 6, 5, 2, lower bound -3, upper bound +3, and I get 0.00, you could actually see the calculator did the 1 minus for me already. So 0.00269, so 0.0027, or as a percent, 0.027%, right? Because my answer is given to me in decimal form on the calculator. Okay, so the next one is between 1 and 2 standard deviations above the mean. And for that one, we're going to go Normcdf. So what I could do here is if I start to kind of familiarize myself with this format, the first number is the lower bound. So if I'm going 1 and 2 standard deviations above the mean, so I'm going from +1 to +2 on the bell curve. So I put a +1, that's my lower bound, a +2, that's my upper bound, and keeping those two values as 0 and 1, which will change later on. And for that one, we get 13.59% or 0.1359, and that actually matches pretty accurately to what we have on the bell curve, right? That was that. All right, so let's try some examples on the next page. A normal distribution of values. You see that phrase? That pretty much is our dead giveaway as normal CDF. The values has a mean of 47, so we're going to be using this as our mu, and a standard deviation of 3.2, so that's our sigma. Find the percentage of values that lie between 42 and 50. So now we're going to be changing those mu and sigma values from 0 and 1 to accommodate the values we have there. So if I go to menu, 652, lower bound, I can actually type in the numbers that are provided here, 42, 50. So I'm going to go ahead and do that. The lower bound is 42. The upper bound is 50. The mu is now 47, and the sigma is 3.2. And I'm going to get 0.7666. So I'm actually just going to go with what the previous page had it as, so 76.6, round up, 6.67%. Find the percentage of values that are greater than 50. So this is kind of hard to kind of wrap our heads around. But if I think about part B here as a bell curve, right, so 47 is right in the middle. 50 is somewhere over here, right, just shy of 1 standard deviation above the mean. And it's asking us to calculate the percentage of values 50 and beyond. So we're essentially calculating all that area that's tracked under the curve there. So for this one, I'm going to go menu 652, right, for our normal CDF. My lower bound is 50. If I'm talking about greater than 50, my upper bound is going on forever, right? There is no end to this curve, even if I'm talking about test scores. And you might think in your head, well, a test score can't go beyond 100. You still have to make your upper bound a theoretical infinity. I can't type infinity into the calculator, so I'm going to type in a ridiculously large number by just doing 10 exponent 99. Again, I set my mu, or my mean, to 47, and my sigma, or my standard deviation, to 3.2, and we get 17.43%. Now, just to show you how sensitive that upper bound is, it's okay if you mess around with it and maybe you don't even go, like 10 to the 99 is a really big number. If I do 10 maybe just to the ninth, that will probably suffice, right? If I just do 10 to the ninth, you could see that that comes out to practically the same thing. But we're always going to play it safe and use 10 to the 99 in case our our sigma is really large, right? Because then it is important to just emphasize a ridiculously large number for that upper bound in that question. Same idea here for part C. Find the percentage of values less than 42. So now for less than 42, that's a little more than one standard deviation to the left. And we're going that way. So for this, when I go menu 652, my lower bound, based on the calculator I'm using, I actually get negative infinity, but yours will probably have a value like negative 10e999, which is essentially negative 10 to the 99. So that's how I'm emphasizing a negatively large number. My upper bound is 42. Mu is again 47, and sigma is again 3.2. And for that one, we get 0.059 or 5.91%. Right, again, that's calculated going that way. Okay, the mean score on a standardized test, so that's mu, and the standard deviation is 110. What percentage of students taking the test scored between 620 and 710? So I'm going to actually try to do this. Again, you can go menu 652 every time if you feel like it saves you time. I'm just going to show you how we can manipulate this on a calculator without going there. First numbers are lower bound. So 620 up to 710 up to, sorry, this value is now our mean, which is 550, and our sigma value is 110. So at this point, I'm actually going to talk to you about how we would show work for a question like this, because we're obviously using the calculator to answer this question. So to show work, we would write Normcdf, and then I'm going to write it exactly as I typed it into the calculator: 620, 710, 550, 110. So this is universally accepted because TI calculators and other types of calculators use this format. And so that comes out to be, since it says percentage, we're going to convert this 0.1894 to 18.94%. I'm just going to try two more, part B and C here, and just stop the video after that. So less than 480. So if I go through, I need a theoretical negative infinity for this one. So negative 10 to the 99 with an upper bound of 480. The same mean and standard deviation. And we get norm CDF. The lower bound when it's less than is our theoretical negative infinity. Upper bound is 480, 550, 110, and we get 0.262 or 26.23%. And the last one here, I'll try to get in before 15-minute mark. And for that one, we're going to go 600 and above. We get 32.47%. All right. I'm going to stop there and leave the rest of these for you guys to practice.